In the realm of machine learning, compute targets are essential for running experiments and training models. They provide the necessary computational resources, whether on local machines, virtual machines, or cloud based clusters. Understanding how to create and manage these targets is crucial for efficient and scalable machine learning workflows. Compute targets are vital because they determine the speed and efficiency of your machine learning tasks. They allow you to leverage powerful hardware, such as GPUs and TPUs, which can significantly reduce training times. Moreover, they enable scalability, allowing you to handle larger datasets and more complex models. There are various types of compute targets, including local compute, Azure Machine Learning Compute, and attached compute. Local compute refers to your personal machine, while Azure Machine Learning Compute includes managed clusters and instances. Attached compute can be other Azure resources or on-premises machines. Local compute is the simplest form of compute target, using your personal machine's resources. To set it up, you need to install the necessary software, such as Python, Jupyter, and Azure Machine Learning SDK. This setup is ideal for small-scale experiments and initial model development. Azure Machine Learning Compute provides scalable and managed compute resources. You can create compute clusters that automatically scale based on your workload. This is ideal for large-scale experiments and training, as it offers flexibility and cost efficiency. You can choose from various VM sizes, including GPU-enabled instances. To create a compute cluster in Azure, navigate to the Azure Machine Learning Workspace, select Compute, and then New. Choose the desired VM size and configure the scaling options. Once created, the cluster can be used for running experiments and training models, providing a robust and scalable compute environment. Effective management of compute targets involves monitoring usage, scaling resources, and optimizing costs. Azure Machine Learning provides tools for tracking resource utilization and setting up alerts. You can also automate scaling to ensure that you only use the resources you need, minimizing costs while maximizing efficiency. Attached compute allows you to use existing resources, such as other Azure VMs or on-premises machines, as compute targets. This is useful for leveraging existing infrastructure and integrating with other systems. To attach a compute target, you need to configure the connection settings and ensure that the necessary software is installed. Experimentation is a critical phase in machine learning, involving multiple iterations of model training and evaluation. Compute targets play a crucial role in this phase by providing the necessary resources to run experiments efficiently. You can use different compute targets for different stages of experimentation, optimizing for speed and cost. Training models on compute targets involves selecting the appropriate target based on the model's requirements. For instance, deep learning models benefit from GPU-enabled compute targets, while simpler models may suffice with CPU-based targets. Azure Machine Learning allows you to specify the compute target when submitting training jobs, ensuring optimal resource utilization. Cost management is a crucial aspect of using compute targets. Azure Machine Learning provides various tools and features to help you manage costs, such as budgeting, cost alerts, and detailed usage reports. By monitoring and optimizing your compute target usage, you can ensure that you stay within budget while achieving your machine learning goals. Security is paramount when using compute targets, especially in cloud environments. Azure Machine Learning offers robust security features, including network isolation, encryption, and access controls. It's essential to configure these settings correctly to protect your data and resources. Regular security audits and compliance checks are also recommended. To make the most of compute targets, follow best practices such as choosing the right type of compute for your workload, scaling resources appropriately, and monitoring usage. Additionally, consider using automation tools to manage compute targets efficiently. By adhering to these practices, you can optimize performance, reduce costs, and ensure the success of your machine learning projects. Creating and managing compute targets is a fundamental skill in designing and preparing a machine learning solution. By understanding the different types of compute targets and how to set them up, you can ensure that your experiments and training processes are efficient, scalable, and cost-effective. Leveraging Azure Machine Learning's features and best practices will help you achieve your machine learning objectives.